very nearly finished this first design phase for the V2 version 2 of the Dex hand, for, dexterous hand. It's got an improved layout. There's 10 servos now in the palm section. Have a quick look at it if we make this transparent. And I've upgraded the wrist motors in the forearm area to standard size servos. So it's a lot more, I guess, powerful, but certainly stronger is what matters. It's also got triple fans in the forearm, because we did burn some out in the V1. And it's a little ugly, but you can also put 2 fans on the back of the hand, and time will tell if that's necessary for all functions. Inside of the fingers is a lot smoother to help with simulation. Thumb might need a bit more work still. Not clear how to do that in computers. So that I'm going to do in physical prototyping, as in I'm going to build it and I'm going to see how the thumb performs. So let's just take a closer look at the hand. It's got a concave palm, should help with gripping. Quite a prominent heel on the little finger side, but again to help with gripping. If we take a look inside, the extender cables have been brought to the outside to make access far easier. At the moment these are still generally done with elastic bands, and they need to be changed far more frequently than any other part of the system. If I can source decent metal springs at a reasonable price that are exactly the right size, I will move over to those. Strangely hard to find. Generally have to buy a kit of hundreds of springs to get the 2 that you want, and I need at least 4 per hand. Interesting to see if there's enough material to make the wrist joint as strong as it needs to be. And there are still these knuckle shells, which are going to need a mechanism to keep them in the right place, and I think I know what I'm going to do, again using springs, just connected at the back there, but that's a little experimental too. Nonetheless, the bulk of the tendons should work almost exactly as the V1. The outer 2 had to go downwards at a considerably steeper angle, but that's just the way it is. And you can see how tightly everything's packed together. Tolerances, try to leave 0.4 for anything which has to move past another component, and 0.1 for the fit. So if we open up the palm, which is made of 4 solid bodies, we can hide the outer shell. Which allows you to see all of the internal detail. This then gets split apart into its 4 separate pieces, and they can get loaded up onto the printer. These are the parts to print the palm, loaded into a slicer, outer cover, thumb support, little finger, and the thumb side. This is the up box slicer, which I'm doing more or less at maximum density, full strength print. Just hit preview and it will slice them up. These have been loaded as 4 separate models, so it'll do 4 sets of slicing. It also means you can't pack them quite as closely together because the rafts will interfere. Although I think I'm pretty near to the stage where I can print without rafts, which will save a bit of plastic and a little bit of time. So that's going to take 8 hours and use 213 grams, and that is printing with a 0.4 layer thickness and a 0.6mm nozzle, which is about as fast as you can print on this machine. Very important, must dry your filament before it goes in, especially with the nylon. Even overnight, it will show a clear difference of printing quality. That lot's come out pretty good. To get them off, you're going to need a spatula or a paint stripper. They should be well bonded, which they are. Platform preheats. 65 degrees. Stability is good. Finish is good, not perfect. Good enough. Really matters on this one. So it could always be done with a finer setting if you really want to get perfect finish on that. This is, I doubt, the final version. Normally use 2 hands for this. See in a moment. The first rule of peeling complex prints, of removing the supports, is always wear a glove. The second rule of peeling complex prints is always wear a glove. Almost done. That's the most complex of them. And if your printer is not set up correctly, that will take much, much longer. So it is well worth taking the time in the beginning to make sure your volumes are set up correctly, your extruded volumes, so your sizing comes out well, and that all of the offsets to allow support removal are well calibrated. Or you can move over to soluble supports or use a completely different printing technology if you have access to it. And eventually, when I know this design is fully correct, or at least correct enough, I shall upload the STL files to iMaterialize, so you'll just be able to buy them perfectly formed and ready to go.
13 minutes. 1 down, 3 to go. This is thumb support. It's a little finger. That's the bulk. And when properly assembled with all the motors, that's pinned and screwed in many places. However, the skin, the shell, can still serve as a structural element. It's nice and tight fitting. This is actually slightly under tension. Which makes the whole thing really very rigid. That's averages about 1.5 millimeter. And then carbon fibre nylon. That's very strong. The last test that can be done for full assembly is just to make sure all the motors fit and can be fitted into printed parts. The tricky one in particular is this deep motor all the way down here. So, correct sequence is to put your wire there, your motor there, and it'll just suddenly pop around. Next on top, also quite an interesting fit. So put the wire like this, so that it engages into the groove. Has to go down flat, of course. I need two. Slides down to the bottom. Final one, you can check the position. It'll be held in place by the thumb insert. And it just goes like that. Then at the front, goes there, and then on the back. That one goes like that. Okay, so that's the thumb side. Tell by the groove where the wire goes. Goes up like that. So it comes down like that. That one slots in there. That one like that. Okay, very nice. No sanding, just peeled prints. That is nice. We'll go like this. Pull these wires forward. That one goes like that. That one goes like that. And then the thumb. Drops over the whole lot. And with all these spare wires, it's no longer possible, I suspect, to fit it inside that. But so long as the motors are not making these parts push apart, which I'm fairly sure they're not, it should fit inside. Again, we shall find out as we get nearer the end. But that for now is as far as the V2 palm assembly has got. Next I'm going to go back, finish the fingers, assemble those, and then connect up all the tendons, and then print forearm pieces, put all the motors in there, and then connect all the electronics, and then put some code in it, and then it should move.